Hey, it's Alex Williams of the New Stack. Welcome to the New Stack Makers, a podcast where we talk about application development, deployment, and management at scale. Hey, Alex Williams here. Finally, we got online. And I'm hoping the sound's going to work out there for everyone who's here at Serverlessconf. My name's Alex Williams. I'm a founder and editor-in-chief of the New Stack, and you can see a little bit over here. We'll actually go over here. You can see that it's where's that input? Yeah, there it is. There's Serverlessconf. Here we are. So I'd like to introduce our guests. Tell us about yourself.
Hi folks, I'm Soam Vasani. I made Fission.io. It's a fast framework for Kubernetes. We released it sometime late 2016, and by now it's a fairly popular fast system for Kubernetes. And I work at Platform 9 Systems, which is a SaaS managed product for infrastructure management of both public and private clouds.
So tell us about Vision.io. Tell us about the genesis of it. How did it come about?
Yeah, sure. So Platform 9 does deployment and management of people's server infrastructure, and we saw a lot of excitement around Kubernetes since early mid 2016, and we would set up Kubernetes for people. We have a managed product to do that, and we find that even though they're very excited about using it, they weren't successful at quickly getting stuff up and running. So, they would ask us how can we become productive on this system, and we just point them at the documentation. That was a very unsatisfying experience for everyone. So we wanted a framework, some tools, some sort of thing that would make them productive and ready on their first day of having a Kubernetes cluster. And meanwhile, we were looking at the serverless and fast movements becoming much more popular, in part because they're so easy to learn. It's so easy for a new developer to understand the concepts around serverless. And we saw that this is a great pattern to apply to Kubernetes as well. So we built Fission, and you can build functions the same way you do, for example, on AWS Lambda, but you can run them anywhere on any Kubernetes cluster, whether it's public cloud or on your own servers.
What did you do to the architecture to give it that capability for, to decrease the friction that developers were having and operators were having?
Right. Yeah. So there were a couple of things to it. One was the sheer number of concepts that you had to learn in the container ecosystem was pretty large, and still is, and it's kind of growing with time.
Concepts such as
deployment services, image registries, the management of versions. How do you make changes? How do you what's the whole flow from your laptop to your production cluster? Even today, if you ask someone who's getting into the container ecosystem, that's an area that every single user still kind of has to build by themselves. So the ecosystem remains a bit of a some assembly required solution. And we wanted something where you learn 2, 3, 4 concepts, functions, environments. Environments are essentially the container wrapper for a function. So that's how you that's how Fission supports Node.js or Python or Go and so on. And then there's triggers, which are how functions are invoked. So you have functions, environments, triggers. If you learn these 3, those are the concepts you need, and you're ready to build things on Fission. And then we have sort of all-in-one tooling to take you from your source code on your laptop to do builds on your cluster, to deploy them, to monitor these functions. We have integration with Prometheus, with monitoring systems, Istio and then you can use open tracing. We also have integration with log aggregation systems, Fluentd, so that you basically get an opinionated, a whole little stack for your functions.
Okay. So you create a stack for your functions.
Yes.
So tell us how you treat the layers of the container then, in the context of that.
Yeah, good question. So an important thing about FAS systems is that you want them to be free when they're idle. That's a big part of many talks in Serverlessconf also tends to be, look how little we pay for our functions, because for example, we pay nothing on the weekends when our users aren't using our app, for example. So we needed a system where we can scale things down to 0 when they're idle. But this also means we need to be able to bring them back up from 0 when there's suddenly a lot of load. So on Monday morning, when everyone suddenly starts using your application again, you need to be able to go from 0 to whatever load you need quickly. And to do that, Fission maintains a pool of containers on Kubernetes in the background. And when a function is invoked, that request is held in memory, function is dropped into a container, and then that request is forwarded into that container. So containers are sort of background implementation detail for Fission, a really important detail, but the user does not really see them or manage them or worry about them.
Okay.
Yeah.
So that required you then to do a lot of almost description, didn't it? I mean, how do you describe these objects that are part of the architecture that come into Kubernetes, a part of the capability for infrastructure?
How does Fission describe it to the user?
Yeah.
So Fission maintains. I spoke a little bit about the idea of environment.
Yeah.
And that's the description of everything between the function and the infrastructure.
Okay.
Right. That's the glue.
Yeah.
And so Fission itself is independent of the language, but obviously your functions aren't. Your functions are in Node, Python, Go.
Yeah.
It's about 10 languages. So we need something that glues these things together, and that's a container. And that is specified using an environment. So the environment is basically an HTTP server that knows how to load a function in a given language. So we have a Node.js, Python environment at various languages, and then the user can enable it on their Fission cluster, and then and now Kubernetes knows how to run containers of that. And now Fission simply has to drop a function into them when that function is needed.
So that's how customers are using it now?
Yes, right. So customers enable whichever languages they want on their cluster, and then create functions. There's lots and lots of examples in the repo. You can create simple functions. You can trigger them using HTTP or using message queues. You can also build larger functions that have lots of dependencies and so on. So there's a build component. Just as I described these containers for running functions, we also have containers for building functions. And then they are also specific to the language that the function is in. And so the user just specifies the source code of their function and what files it's in and things like that. And then the Fission tooling takes care of packaging, uploading into your cluster, watching the build, telling you if the build failed and so on. And if it succeeded, then it goes on to be deployed on your cluster automatically.
So what version are you? Where are you now with the project?
We are nearing 1.0. We've been pre-alpha, we've been pre-beta for a while in alpha stage. We're currently beta. Our version is at 0.9 right now. And we're looking at 1.0 later this year.
What are you thinking about for 1.0? What will be some of the major features
Feature-wise, we're actually trying to slow down the features, and we're trying to do much more comprehensive testing around Fission, around its performance, around clusters that last a long time. At Platform 9, we have a cluster that's we had a cluster that was up like 6 to 8 months. It worked really well. We like to show people tests that this thing has been running for such a long time with so many millions of requests or whatever, so that they can feel confident about about what they are using.
Right.
In terms of features, the missing pieces today right now tend to be a little bit around the operability in general, around making this even easier to monitor and diagnose problems with, to debug problems with. We're working on debugging integration, so you can do one command and you get dropped into a debugger for your function. We're working on better observability into all aspects of your functions. So we already have Prometheus metrics. We're trying to integrate open tracing. You can already do that with Istio, but in case we want more direct support for tracing. So most of the support is around things like that.
Tracing seems to be one of the real buttons that needs. I mean, really one of the kind of real issues out there that is it kind of in terms of like a lot of different efforts going around that.
So the open tracing folks built a standard.
But just generally not just with you, but open tracing is becoming a larger issue, isn't it?
I think it's great. It is a lot of work to actually make all the pieces work together so you have tracing. But hopefully our framework can help with that because we wrap your function so you can actually get tracing for your function through Fission itself without adding it to your application code. But tracing is one of those pieces that really helps you drill down into the performance of your system.
Right.
One of the hardest problems to answer in complex distributed systems is why was something slow? Especially if it was slow, if someone tells you, hey, your app was slow last week, that's kind of like developers think of that as a bit of a nightmare to debug because I do not have enough information to do anything about that today. But we want to get there.
I see. When you do get those reports of those latency, you may have the data to be able to look back in time and observe some anomalies.
And really drill down and say that component. So we have metrics today, but metrics are very aggregated. So we can verify, we can tell if something was slow at some point, but we can't really diagnose it. So tracing helps with that.
Great. Well, thanks so much for taking some time. So I really appreciate it.
We
had a little difficulty getting things set up here, but thanks for your time.
No worries at all.
Take care.
Yeah. Take care.
Listen to more episodes of the New Stack Makers at thenewstack.io/podcast. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.